Welcome to methamphetamine. Today we are going to do the integral of psi of arctanx times inverse tangent x going from 0 to 1. So look at this integral, and if this is an definite integral, if this is an indefinite integral, and this integral looks really impossible, right? Because you have a psi of arctanx times inverse function. If you use the integration by part, I think you just can't do this integral in a elementary way, but this integral is evaluating from 0 to 1, going from 0 to 1. So but this time is a really special integral because I'm going to use two things. One is the real and imaginary part, and second one is use the summation side because this integral looks really impossible. But this integral is going from 0 to 1 as I mentioned before, so we can actually use the series. But when the upper limit is infinity, we cannot use the summation. Be careful. So, but this time is 1, so never mind. So I'm going to take a real part of this first, or imaginary part. Psi, we should take an imaginary part, right? But to figure out what is psi of arctanx, we need to use the arithmetic formula, which is e to the power of ix is equal to cosine of arctanx, cosine of x plus I sine of x, and then we are going to put arctanx inside the x, which is cosine of arctanx plus I sine of arctanx. So you can simplify this more because of the log property. You can actually bring this I into the power into the x, which is x to the I. So you can cancel out the e and ln, so you can get x to the I, right? So you can get the imaginary part of the x to the power of I, which is equal to psi of arctanx, and then the real part of x to the I, which is equal to cosine of arctanx. But this question is psi of arctanx, so we should use the imaginary part, right? So because of the property, you can actually bring the imaginary part outside the integral, imaginary part of x to the I. I don't put down my parentheses here because you can also put down my parentheses, but why I put down my im without the parentheses side, you ask me, because I'm just lazy. I like to write this way. So if you are doing an exam, but I'm not sure your teacher can let you do that, but so be sure you need to add down parentheses. But I think you don't put down parentheses, that's okay, because you take a im. This one is im of x to the I. You bring it outside im of x to the I. Never mind. If you don't put down parentheses, okay. So im of x to the I, and then the summation of inverse tangent x, which is equal to the summation n is equal to 0, then infinity, and then 2m plus 1, and then on the top you get negative 1 power of n times x to the power of 2m plus 1 dx. So because of the properties, you can switch the order of the summation sign and the integral sign. So I'm going to put down a summation sign here, and then you are going to integrate this, right? But this one is just a constant, so you can put it outside the integral. So put it on this summation, in this summation, and then 2m plus 1, and then we are going to multiply by the integral of, just add the power, right? Add up the power, you get x to the power of 2m plus 1 plus I dx. So let's keep continuing. Let's continue. And this one, you pretty much just add 1 to the power and then divide it by the new power. So I'm going to just give it really quick, which is 1 over 2m plus 2 plus I. And then that's x, you just evaluating from 0 to 1. You actually just get this really quick. So, what should we do next? 1 over 2n plus 2 plus I. Outside we have an imaginary part. We are going to multiply by the conjugate of this, which is 2m plus 2 minus I, on both the denominator and the numerator, right? So, because we are going to get the real part and then the imaginary part later. So, we are going to write this as, and then the top stay the same, right? 2m plus 2 minus I. But this one is not the same. We're going to use the formula a plus b times a minus b, which is this square, this whole thing square, and the minus I square, and I square, which is -1, minus that, you will get +1. And this one, you pretty much just get this square, you get 4n square, and then plus 2 times 2n plus 2, which is an, and the 2 square, which is 4. So you are going to get this one, and then times 2n plus 2 minus I over 4n squared plus an plus 5. Whew. And then we can split it to 2 parts, which is our real part and then the imaginary part. So the real part is just 2m plus 2 over 4n squared plus an plus 5. And then the imaginary part, let me just put down a negative here, and then 1 over 4n squared plus an plus 5, and then times I, right? Sorry, I split. So obviously you can see when you distribute the summation sign, this summation is always gonna be a real number, and then when you distribute this summation sign, you get the imaginary summations, right? So the imaginary part, which is just this, so far your answers is gonna get our summation n is equal to 0, and then this one, let me just put a negative sign outside, and then put down a -1 power of n, and then over 2n plus 1 times 4n squared plus an plus 5, and then that's our answers, right? That's the imaginary part. And you can bring the -1 inside to get a +1 here, but if you don't do that, that's okay. So leave a negative sign outside the integral. That's okay. So here is just our result. So you can also know the integral of cosine of ln x times inverse tangent x dx. So you are going to take the real part of this, which is just the summation n is equal to m from 0 to just summation, and then I'm going to factor out the 2 outside. You get 2 times this, and then -1 power of n times m plus 1 over 2m plus 1 parentheses times 4n squared plus an plus 5. And here's our result. And I don't think we can simplify them anymore, so I might leave these answers to you guys. So when you put the result of when you put the integral on the Wolfram alpha, it won't give you the closed form, but we have find the summation form, and that's okay. That's just okay. It's better than no form, you know. And Wolfram alpha just give me the numbers, and that's it. That's really cool. And I hope you guys just enjoy this video and peace out.